Hello students, this is Professor Kiran Poddar, Angadi Institute of Technology and Management. Now we'll discuss an example on cumulative distribution function. Find the cumulative distribution function for the probability density function of a random variable x. F of x is equal to 6x minus 6 square, where x lies between 0 to 1. Otherwise it is 0. Means what? If the line, if you take real line x, it is 0, then this side it will be up to infinity, it is minus infinity. If the value of x is 0, 1, means in between 0 to 1, the functional value will be 6x minus 6x square. Other than that, it will be 0. Okay, only it lies between these two terms. And we need to go through cumulative distribution. What is the meaning of getting cumulative distribution here? That is very important one. Previously in discrete, whenever we need a cumulative, we formed a distribution table. Then after that distribution table, for example, if we wanted a fifth cumulative distribution of a fifth term, then we added initial to fifth all the results probabilities we added, so that become a cumulative distribution function value. But here it is related to integration because it is a continuous function. So here how the things will move. Cumulative. So first once I want to just go through the definition of cumulative distribution once. Okay, so let us take what is the meaning of cumulative distribution here. If x is a continuous random variable with a probability density function f of x, then the function f of x is what? All the time the cumulative distribution, even though it is between minus infinity to plus infinity, but here the things will lie between minus infinity to the fixed value of x, whatever the x we are going to take, that into f of x dx. Fine. So this becomes, sometimes we need to take this also, that is the differentiation. If it is required, we'll take, otherwise not necessary to take, or else we'll continue only with this formula. Okay. So in this case, what to do? Here, very first, if the function f of x is a probability density function, then cumulative density function will be taken as f of x is equal to integration between minus infinity to x, f of x dx. This is the formula. Okay, and here how the things will move? We'll take it as f of x is equal to integration between minus infinity to x. Between minus infinity to x, first I'll take here only. Then this minus infinity to x, how it will be distributed? It will be distributed as minus infinity to x value, whatever the x we have fixed up till that, how it will be distributed. We all know that it will be distributed between minus infinity to this point of 0, where f of x into dx, plus then from that value of 0 to the fixed value of x of f of x dx. Okay, further what happens? Then it will move from x to infinity, that is again 0, no problem. Therefore we got f of x is equal to integration between, because we know that the value of this between minus infinity to 0, the functional value will be 0. This is gone. Then second one, here the functional value is given, but that depends on which kind of x. That x must lie between 0 to 1, but here we take in general x, so it is 0 to x f of x dx. Fine. Therefore integration from 0 to x into f of x. What is f of x? Designed f of x here, 6x minus 6x square with respect to x. So let us calculate this. Then integration of 6x, that is 6x square by 2 minus 6 times integration of x square is x cube by 3. This is between the limit 0 to x, because we have not yet specifically we have taken the value of x. So this is equal to 1 za 3 za, so it is 3x square minus 1s are 2s are, so 2x cube between 0 to x. This is f of x. Therefore, f of x is equal to, substitute upper value as x in x, so it won't change. So 3x square minus 2x cube. Lower value, if you substitute 0 here, then 0 minus 0 is 0. So this is the designed value of f of x. Fine. So this is the designed value of f of x which we got. Therefore, this becomes a cumulative density function for the value of x lies between 0 to 1. So this becomes the cumulative density function. Thank you.